Hi, I'm Kriparna and I'll be your mathematics teacher for today's class. So let's quickly go over our topic for today and we are going to start. So here we go. So our topic for today's class is graphing in the XY plane. It's a portion of Cartesian geometry and we're going to learn about it today. Graphing in XY plane. Now, what is the XY plane? See, it's a plane which contains two lines, straight lines, the x-axis and the y-axis. So the x-axis is a horizontal line. Let's just draw it here, just a second. Yeah. There we go. The y-axis is a vertical line. Right? Now, yeah. Now this would be x and this would be y. Now, any point in this plane is denoted with a system of coordinates. So let's say we write a point P. Then to locate it and differentiate it from all the other points in this plane, we give it a unique set of coordinates, which is x1, that's the x coordinate, basically meaning the horizontal distance from the y-axis, and y1, which would be the y coordinate, which means the vertical distance from x-axis, right? Let's say we plot another point here, which is q, and q is x2, comma y2. Now we join these two and we see further. There we go. Now when we have points, 2 points, and their coordinates are given to us in the XY plane, we can get a lot of information from that about this line segment PQ. What are the things that we can find out from here? First, we can find out the midpoint of the line segment PQ. So here, let's say it is a point M, which cuts the line segment PQ into two equal halves, which means bisects it, right? We can find the coordinates of M very easily. We know this. So M would be equal to MX would be, the X coordinate of M would be equal to X1 plus X2 by 2. And the Y coordinate of M would be equal to Y1 plus Y2 by 2, okay? We can then find the distance from P to Q, or the length of the line segment PQ. How do we find it? Well, from the distance formula, we know this. We probably have memorized it since 8th grade. So the distance formula, we use that and we get PQ is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Now, knowing the formula is awesome, which is what we will need when we solve the questions. But it's also important that we know where this formula comes from so that we don't feel like it's something too complicated. And also, the deeper the understanding of where something comes from, the easier the problems, become, right? So it's a very simple derivation. We can get it from the figure itself. So let's say I drop few lines from Q, just one line from Q to X and one line from Q to Y, like this. And the same way, I drop a straight line from P to X and from P to Y. Why am I doing this? Just to have lines that quantify the X and Y coordinates of P and Q, okay? And I'll also join P, and I'll also join P here like this. So there will be another triangle formed, PQR, which will be a right angle triangle. Okay. Now, let's go ahead and see what we get here. This is x1, right? This would be x2. In the same way, this is y1, and this would be y2. Right? Now, if we find out just this much, which is this portion, that is equal to y2 minus y1. So QR is equal to y2 minus y1. And similarly, PR is equal to x2 minus x1. Now, in right angle triangle, there You don't have to write right angle, that's visible from the figure, but okay. Right angle triangle PQR. We can apply Pythagoras theorem because it's applicable in any right angle triangle. And we know from Pythagoras theorem that the square of the hypotenuse is equal to the sum of the squares of the perpendicular and the base, right? So we know that PQ, I'll use a different color. So PQ square, PQ is the hypotenuse, right? Opposite to the right angle. PQ square is equal to PR square plus RQ square, right? Now, PR is x2 minus x1 as we see here, and QR is y2 minus y1. So we just simply put it here and we get x2 minus x1 whole square, that's PR square, plus y2 minus y1 whole square, which is RQ square. Now, square rooting both sides, we would get PQ is equal to under root of x2 minus x1 square plus y2 minus y1 square. So it's a very, very simple derivation, but it's good to know, right? Because otherwise it just seems like a huge mathematical formula, but now we know where it comes from. Now, let's go further. Here we go. Now we are going to see what more can we find from 2 points whose coordinates are given to us in the xy plane. So here we go. Okay. This is P, this is Q. So from PQ, x1, y1 and x2, y2, we can find the slope of the line segment PQ. Now, what exactly is slope? If we try to understand it in the most basic way possible, no mathematic mumbo jumbo, then slope is defined as how easy or difficult a particular climb would be on a straight line, right? Which means how steep or flat is the line. Now, for example, if I say, if we have a line, let's say this is a line with slope 1, and this is a line with slope 2. Right from the figure itself, we know that if a person's climbing this one, they would have a much easier time than if someone was trying to or daring to climb something like this, right? So that's what slope is. It's the measure of the tilt or the inclination. Now, how do we actually mathematically express it? Let's see. So mathematically, we express slope as the ratio between height and the walk or the base, which means the rise and the run or the walking distance. So for example, let's say you start from P and you reach Q, your travel or the distance you have traveled will have 2 components. You will gain 2 things here. First, you will climb a height, and second, you would move horizontally forward, right? This and this. That's what slope is. We also know it as tan theta perpendicular by base. The tan theta angular notations are not very important here. However, the formula for slope in terms of the coordinates is crucial. So we denote slope as n here, and it comes out as, let's see what will it come out as. Okay, so again, we have the same way. This is QR, PR. Now the height when someone travels from P to Q, so from here to here, what's the height gain they are going to have? It's QR. That's their height. And we know QR would be equal to y2 minus y1, right? How do we know that? Well, simply because if you join this much and you know this is y1 and this much is y2, then of course the difference between them is QR, which is y2 minus y1. In the same way, this is x2 minus x1. And we get it. So M would be equal to the ratio of height, which is this, over walking distance or base. So y2 minus y1 by x2 minus x1. This is something that we widely use in any geometry straight line questions that we get in ACT. It can also be used not just for geometry, it's used for problems that have x and y in linear conditions. The slope helps us know the rate of change of y with respect to x. We are going to see that in some time. Okay, so this is what we can get from PQ. Now let's go to equations of a line. Okay, what does a linear equation look like? Why is it linear? What are the differences from other types of equation? Stuff like that. So let's say I have an equation 2x plus 3y equal to 12. Okay. Now, from here, what can we say? What is something that we know from this equation? We know that it's called a linear equation for sure. It has two variables, x and y. We can see that as well. And that's about it. Actually, that's not about it. We can also draw it in the xy plane. We'll see how. Now, why is this called a linear equation? Simply because if we draw it in the xy plane, it comes out to be a straight line. We'll see, right? Let's say we have the xy plane right here. Here we go. Okay, and we are going to plot 2x plus 3y equal to 12 here. So this is x, this is y. Now, when we plot, the first thing that we need to do is make sure whenever we plot a graph for any equation, our goal is to capture the entire equation, which means all the points that can lie and satisfy this equation should be covered by the graph. That's what a graph does, right? It portrays an image of all the points that satisfy the given equation, right? So of course, we can just get 2 points from this equation, very simple 2 points, and we join them and we should get our straight line. That's one of the very fun things about drawing a straight line, is that you only need 2 points, because with 2 points, there's only one line that can pass through 2 points, any 2 points. Okay. So what we are going to do is we are going to use the intercept form for getting this equation, as that's one of the easiest ways to draw it. So what is the intercept form? It basically involves finding the x-intercept, which is nothing but the value of the equation when y coordinate is 0. So value when y equal to 0. So in this particular case, the x-intercept would be, let's see, if we put y0, 2x plus 0 equals to 12. So x equals to 12 by 2, x equals to 6 should be the x-intercept, right? Now, in the same way, we have the y-intercept, right, which is again value of the equation, value of y when x is 0. So this is value of x when y is 0, and this is value of y when x equal to 0. So again, we put x equal to 0 here. So 0 plus 3y equals to 12, and we find out y is 4. There you go, y equals to 4. Now it's simple, we just plot it here. So we have, let's say 1, 2, 3, 4, 5, and 6. We have 1, 2, 3, and we can go more obviously. Okay. So now we just draw a line that goes through the y-intercept, which is 4. So this much is the y-intercept here. It should go through that. And we have the x-intercept as 6, which is here. Right. There you go. So we're just going to draw a straight line through this. And that should give us our line segment or straight line that covers or represents the equation 2x plus 3y equals to 12. This will contain all the points that satisfy this equation, and that's about it. So from here, we can find out, like, there will not be a single point which has both x and y negative and lies on this line. Do you see? Because the only 3 quadrants this line will cover is this one, and this one. So that's what, like, fun. That's the fun of drawing graphs. You can know exactly what you're doing here, and there's no guessing work. You just draw a figure, and that's it. You get a lot of information from it. So that's the graph that we draw from x-intercept and y-intercept. Now coming to few other pieces of information we can get from this equation. First, of course, the slope. What's the slope of this line? And that's about it. So for the slope, what we can do is we just simply write it in the form, in the slope intercept form. So what is the slope intercept form? It's basically one form in which a straight line's equation can be written that gives us the information on the slope and the y-intercept, right? The y-intercept and the slope. It looks like y equals to mx plus c. M is the slope and c is the y-intercept. Why is c the y-intercept? Simply because you put x as 0 here, y equals to c. And that's what y-intercept means, right? Value of y when x equal to 0. So you put x 0, you get c. That's your y-intercept. Now m is the slope. That's about it. So from here, if we want to find the slope, what do? We simply write it in the slope intercept form. So which means y should be on the left hand side. So 3y equals to minus 2x plus 12. Then we reduce it. We just divide it by 3 because we only want y on our left hand side. So y equals to minus 2/3 x plus 4. And you see that this is exactly what, oops, I'm sorry, just a second. Yeah, this is exactly what y equals to mx plus c should look like. So I'm just gonna, yeah, there we go. So here m would be equal to minus 2/3. And our y-intercept is 4, which of course we can verify because we already calculated it and it was equal to 4 as seen from here. Okay. Now let's go to find out what are the various interpretations of slope. Because slope is important. Slope kind of defines a line's properties, its inclination, its definition, and the direction it moves in, everything about it, right? So we're going to learn how do we interpret slope and what does it actually mean in respect to a straight line. So interpretation of slope. There we go. So let's say we have a line y equals to mx plus c. Now we know m is the ratio from between height and base. We can also express it as rise slash fall with respect to the walking distance or run. So yeah, there are various ways you can express it, but the main thing is it's the ratio between the height you gain and the distance you move horizontally, right? So that's m. Now we know m is equal to y2 minus y1 by x2 minus x1. Right? Let's say we have a line, equation of a line that looks like y equals to 5x plus 3. Okay. Now from here we know this exactly looks like y equals to mx plus c. So we know m is equal to 5 and c is equal to 3. M is equal to 5. What does that mean? That y2 minus y1 divided by x2 minus x1 is equal to 5. Or we can write it as 5 over 1, right? Now if you see, that implies or that clearly translates to for every unit increase in x, there's 5 units increase in y, right? Increase in y. Now we know this is increase, it can be decrease as well, right? If this was minus 5, then we would say for every unit increase in x, there's 5 units decrease in y. We are going to learn that and the different types of slope and everything in some time. But for every unit increase in x, here there's 5 units increase in y. That's basically what slope interprets to. It's kind of quantifying the rate of change in the difference of y with respect to the rate of change in x. Okay. Now going to types of line and their slopes. So let's see. We are going to draw the coordinate system and a few straight lines, and we are going to try to see what their slopes would be just from the image of the line or just from the graph. Okay, so here we go, X and Y. So first, let's say we have a straight line. This is A. Okay. Then we have another straight line, which is B. Right. Now, just by looking at it, we know that B is steeper than A, right? Steeper means the height of B is more than the height of A. And we know the slope is equal to height over base. So if height is more, slope is directly proportional to height. So slope is more, which means the slope of B is more than the slope of A, right? So steepness, the more steep the line, the higher the slope. Okay. In this particular scenario, but yeah, always also. Now this is A, this is B, we can understand. Next, let's say I have a straight line that looks like this, right? Okay. And this is C. Now, what is the slope of C? How do we find this out? Well, again, we go back to our formula, very simple core concept, which is slope is equal to height over base. And just a second, yes, slope is equal to height over base. Now here, if you see, for C, we don't have a height, right? I mean, see here, if you see, we don't get any tilt or inclination. It's zero. The height is zero. We are moving horizontally forward, but between 2 points on C, let's say here we have someone and they are walking till here, they are still at the same height, which is this much, right? No height gain whatsoever. They did move horizontally forward, but no height, which means your slope would be 0 over the distance they moved forward. So that's, let's say, x2 minus x1, right? 2 points we are considering here, which is equal to 0, because 0 over anything is 0. So the slope of this line is 0, which means anything that's parallel to x-axis is 0, right? So first thing that we know is anything that's like this B is steeper than A, and if something's steeper, that means it has higher slope. And then we know, and these are both ascending lines, right? Both with like X increasing, the Y also increases. And here we know that B is steeper than A. We also know that these will have positive slopes. Why? Simply because here again, as we said, Y increases as X increases, so it's positive. If Y would decrease as X decreases, which would look something like this, then that would be a negative slope. Okay, why? Because here as we move forward, we are actually going down, right? Which means the height is reducing or we are falling as we are moving forward. So in this case, in case of line D, our slope is negative. In case of lines A and B, our slope was positive because in both of these cases, with X increasing, Y was also increasing. You see, as we move forward, we are also rising up. As we move forward, we are also rising up. So slope is positive for B as well. Slope of B is greater than A, but both are positive. For C, we just calculated slope is 0. Now, there's only one type of line, straight line, that we still haven't seen here. Let's try to draw that. Let's say there's a straight line that looks like this, which is basically parallel to the y-axis. Now, what's the slope of this? We again go back to our core formula, which is height over base. We know it's the ratio between height and base. Now, height, we keep on gaining height here, but there's no base. Like there's nothing to walk forward on. You cannot constantly keep on gaining height when you don't get to move. Like, you know, that this literally looks like flying and we can't do that, right? Here the base is 0. There's no base gain. Height gain is, well, huge. We can say it's infinite, but actually it's not defined. It's absolutely not defined because this is not possible in real life. So in this case, our slope is not defined as base is 0 and anything divided by 0 is not defined. So in this particular case, line E, the M would be not defined. I'll just draw it with a different color because too many arrows. Yeah, M is not defined. So if we quickly had to categorize the types of lines and their slopes, we know an ascending line, M is positive. A descending line, M is negative. Line parallel to y-axis, parallel to first let's do x-axis, line parallel to x-axis, slope is 0. And line parallel to y, okay, I'm so sorry, that is not how a line parallel to x-axis would look like. So this is line parallel to x-axis, M is equal to 0, and line parallel to y-axis, which is vertical, that would be M undefined. M means slope. Slope is not defined. This is about it. Now we are going to try to solve few problems with these concepts and see how we do there. Okay, so first, let's say Sam works at a restaurant. Right? When he leaves for work on one particular day, he has $45 with him. For work, he has $45 with him, right? Now he works at a restaurant as a waiter and he gets his pay on an hourly basis. So for each hour he works, he gets his pay. And his pay is $16 per hour, right? And Sam works X hours for this day, right? Sam works X hours. Now, how much money would Sam have with him at the end when his work shift is over? Let's say we denote that as Y. Y is the total money he would have with him, right? Now, our goal here is to express Y in terms of all the information that's given to us, right? So Y should be equal to, firstly, he works for X hours, and for each hour, he gets $16. So the money he earns during his work is $16 times X, which is 16X. That is not all, because we're talking about the total money he would have with him after his work shift is over. So we have to add the additional $45 he had with him when he left home. So plus 45. This would be the linear expression that completely captures the situation of Sam leaving home with $45, earning $16 per hour in his work day, and then calculating the total amount he has after that. Right? Now, if we try to see and draw it in a graph, we would get something like this. So, again, we can see that the equation here is in the x slope intercept form. So we already know the y-intercept, right? What does the y-intercept imply? First, let's see it in a practical setting, and then we are going to go ahead and draw it. So y-intercept means the value of y when x is 0. We know that. Now, in this case, x is 0. Now, in this case, we know y is the total money, total amount of money, Sam has at the end of the day, and X is the number of hours Sam has worked, right? Number of hours Sam has worked. So y-intercept means value of y when X is 0, which means how much total money does Sam have when he hasn't even worked a single hour. His number of working hours is 0. How much money does he have? Very simple. He has $45, as we said. When he leaves for work, which means he hasn't started work, he has $45. So Our answer to y-intercept, which is value of y when x is 0, is 45. As we can see here, but practically that's what it implies with respect to this problem. In the same way, we have 16, that's our slope. Okay, slope, if this is a straight line, this is a straight line, then that will be our slope 16. And what does that imply? We'll see once we draw this. Okay, so first we have the y-intercept at 45, let's say, and we draw a straight line. So would it be an ascending straight line or a descending straight line? Well, that should be simple because we know if the slope is positive, it's an ascending straight line, right? And here the slope is positive, right? Here the slope is 16, which is positive. So we know it's gonna ascend. So that's the straight line we are gonna get. And after that, we know that the slope is 16. So let's see how it interprets. This is the straight line that covers Sam's work shift and the equation that captures it. And here n is 16, which means for every unit increase in his working hours, which means for every extra hour he works, his income increases by $16. Let me say it again or write it again. So what does slope mean? It means for every unit increase in X, what's the increase or the increase in X? The increase, the number of units increase in Y, right? In Y. Now here we know X is the total number of working hours. We forgot to label the axis, which is actually very crucial because otherwise this graph will make no sense to anyone. So this is the number of hours Sam has worked. That's what we describe in the x-axis. Also, usually in any graph, actually always in any graph, the x-axis usually contains the independent variable, which means the variable that will keep on changing and altering irrespective of whatever happens around. So for example, x denotes the number of hours, right? And hours is time, and time constantly keeps changing. It doesn't actually stop for anyone, so it's independent, and that's what goes on the x-axis. On the y-axis, we are going to have the dependent variable, which is the total money, which absolutely depends on the number of hours he works, right? So this is not independent. This depends on the other variable, but X doesn't depend. X does not depend on the number of hours will never change based on how much money he's making, right? So that's what independent and dependent variables mean. And here, if we see, for every hour increase in Sam's work, he makes $16 additional money. That's what M equals to 16 symbolizes. And that will be it, I think. Let me just, yeah. I hope I could explain the topics. For any further questions or clarifications, you can obviously reach out. And if you want to tell me right now, I would love to help you out with that. And thank you so much. It was lovely taking the class with you and hope you have an awesome day ahead. Thank you. Bye-bye.